So hey guys, the first question of the contest was Abhishek's free Vada pav. It was a fairly easy question with just 10 points, and most of the people could solve it correctly. The question goes like Abhishek goes to the college canteen and asks for a Vada pav. The canteen Anna tells him that the pavs are finished and that Abhishek would have to bring in some pavs from a nearby bakery. Anna also tells Abhishek that he would be given free Vada pavs for the rest of his college if he brings the required number of pavs. Now, the Anna provides Abhishek with the number of pavs he will require to run the canteen, and Abhishek needs to buy those many pavs from a bakery and bring them to the canteen. However, we know that the bakery doesn't sell pavs individually, they sell them as ladis of pav. And we are very familiar that each ladi of pav consists of six pavs. So the question is fairly straightforward in terms of what it provides and what it requires. It would provide the number of pavs n that the canteen Anna would require, and we need to provide L, which would be the minimum number of ladis that would fulfill Abhishek's requirement. So we would be given n, which is the number of pavs, and we would need to find L, which is the minimum number of ladis. Stress on the word minimum. The constraints are fairly weak. They aren't so high that you need to use some special data type. An integer would work. And let's find why this word minimum was put here. The first zero sample test case is n is 12 here. That is the number of powers, and we know that since there are 12 number of powers which are required, I can directly find that 12 by 6 is 2, so 2 ladis would fulfill that requirement. Like 6 powers requirement can be fulfilled by 1 ladi, 12 powers with 2 ladis, 18 powers with 3 ladis, and so on. And similarly, coming to the first sample test case, where I've been given a requirement of 15 ladi of 15 number of powers, the output expected was 3. Why is it so? Let's see. If I directly divided 15 by 6, then in that case, this would be integer division. And since this is integer division, that would lead to just truncating it to the integral part. And the integral part of this division would be 2. But we know that if we just by 2 ladis, then that would only consist of 12 powers. And this falls short of the required number of powers. Our required number of powers is 15. So what we can do is we can find the next nearest number of ladis, right? We can find we can bring 2 plus 1, which is 3 ladis. That would consist of 18 pows, and that 18 pows would be more than sufficient to fulfill the requirement of 15 pows, and that would also be the minimum number of ladis that would fulfill the requirement. 4 ladis can also fulfill it, 5 ladis can also do it, but 3 would be the minimum such number of ladis. So that is what we need to find, L. I think we have understood from the question one thing, that in the case when n, which is the number of powers, is directly divisible by 6, the answer would be n by 6. But in the case when that is not divisible by 6, we need to find n by 6 and plus 1. Plus 1 because I am truncating the division to a single integer, so that would cause it to go to the previous nearest integer, and I need to find the next nearest integer. So I would add 1 and go to 3. So let's just solve the question. The input format is the first line contains a single integer n. So we would firstly input n, and I need to output l. So another thing is, alright, now let's calculate l. As we had discussed, if n is directly divisible by 6, in that case l would be just n by 6. And in the case when n is not directly divisible by 6, like in this case 15, my L would be n by 6 plus 1, and I would output L. Let's submit this. So that is an accepted solution. One other thing you could have done here was, and this can be pretty useful to you in your competitive programming journey. Rather than making such conditionals, you could have made the use of uh, floating point division. What I mean by that is, let's say the problem of adding one arised from the fact that integer division truncated my answer to 2, whereas I wanted 3. What I could have done is I could have taken some double or some float, let's say the ladis, and I would have said that let this contain the floating point division of these two numbers. Now this wouldn't work because we know that n is also an integer and 6 is also an integer. So either I typecast this to a floating point number, or I can just say this is my floating point number. And this would contain some ladis of power, which is the result of this integer, this floating point division. Let's just say that is 15 by 6 is, let's just say something 2.5. If I have 2.5 ladis, I obviously can't output 2.5 because I need a single integer L, right? So what I can do is I can find the next nearest integer of 2.5. So any number which is in the range from, let's say, 2.01 till 2.99, the next nearest integer for it would be 3. And what do we call this 3 as? We actually call this as the ceiling. In programming, you would have two terms, floors and ceilings. So floor for 2.01 to 2.99 would be 2, whereas the ceiling would be 3. So the ceiling is something like GIF, the greatest integer function. So we can do that as well. We can directly output uh, the ceiling of Ladi. Let's just submit this.